Given sec theta equal to 13 by 12, calculate all other trigonometry ratios. So sec theta is 13 by 12. We also know sec theta is hypotenuse over base. So we can say hypotenuse equal to 13 on comparing base equal to 12. So if I draw a triangle here, if I draw, this is a triangle, and in the triangle we have A, B, C. We take A as theta, and in this case we know this is perpendicular, here is the base, and this is the hypotenuse. So we can now write hypotenuse as 13k and base is 12k. So this is 13k, here is 12k, and we need to find our base, find our perpendicular. So in triangle ABC, using Pythagoras theorem, AC square equal to AB square plus BC square. Now AC is 13, so it is 13k square equal to AB, we see is 12k square, and we need to find BC square. So 169k square equal to 144k square plus BC square. 169k square minus 144k square equal to BC square. So on subtracting, we get 25k square equal to BC square. So 5k will be BC. That means for perpendicular I will write now 5k. So in this one we know our hypotenuse is 13k, the base is 12k, and the perpendicular is 5k. Now you can find all the ratios. Like if you want to find sine theta, perpendicular over hypotenuse, and this would be, in this case it would be BC over AC, which is 5k over 13k and 5 over 13. Then if you know sine theta, you also will know cosec theta. So I write cosec theta is just a reciprocal of sine theta, and cosec theta hence would be 13 by 5. Then next you can find is cos theta. That cos theta also, you know, since sec theta is given as 13 by 12, you know your cos theta will be 12 by 13. Then for tan theta, I'll do it in the same. You know your tan theta is perpendicular over base, and in this case our perpendicular is 5k and the base is 12k. So tan theta is 5 over 12, and if tan theta is 5 over 12, your cot theta, which is reciprocal of 10, will be 12 over 5. Prove that 1 plus sec a over 1 minus sec a equal to 1 plus sine a over 1 minus sine a equal to sec a plus tan a. So let me write this. And 1 minus sine a. Then you multiply the numerator and denominator by 1 plus sine a, and this also 1 plus sine a. So here we have now in the numerator 1 plus sine a, 1 plus sine a, it will be 1 plus sine a the whole square. Denominator a, this is a plus b minus b, a plus b. A minus b, a plus b is a square minus b square. That is 1 square minus sine square a. So this is under root 1 plus sine a the whole square over cos square A. So when you remove the under root sign, you'll get 1 plus sin A over cos A. Now you separate it out, 1 over cos A plus sin A over cos A. 1 over cos A is sec A, and sin A over cos A is tan A. If you can recollect, for this we know 1 minus sin square A equal to cos square A, and that's exactly what we have written here. In triangle PQR, right angled at Q, PQ is 3 centimeters and PR is 6. Determine QPR and PRQ. Let me start with this, how to determine this angle theta. We'll take this as theta. If R is theta, here we have perpendicular and this is the hypotenuse. So we have sine R, perpendicular hypotenuse is sine. Sine R is perpendicular over hypotenuse, and in this case PQ over PR. So sine R, PQ is 3 centimeters and PR is 6 centimeters, which is given to us. So sine R equal to 1 by 2. Now we know sine of 30 is 1 by 2. So when we compare both these here, we'll know that R equal to 30. So in this triangle, that is triangle PQR, here R is 30 and this is 90. Now we need to find P. So in triangle PQR, we have P plus Q plus R equal to 180. So P we do not know, Q is 90, R we found is 30 equal to 180, and then you'll find your P as 60. Remember, this is by angle sum property. If 3 cot A equal to 4, check whether 1 minus tan square A over 1 plus tan square A equal to cos square A minus tan square A. So let us start with 3 cot A equal to 4. So cot A is 4 by 3. If cot A is 4 by 3, we can say tan is reciprocal of cot. So tan A is 1 over cot A, and that will be 3 by 4. So this is important and we are going to use this. Tan A is 3 by 4. Now we also need to find cos square and sin square A. So for that we draw the triangle. So here we have the triangle. We'll call it ABC. We will find this angle A. For this angle A, here is the perpendicular, this is the base, and this is the hypotenuse. Now it is given to us that tan A is 3 by 4, and we know tan A is perpendicular over base. The perpendicular in this case is BC and the base is AB. So on comparing, I can say BC equal to 3K and AB equal to 4K. So I'll put that up now. Now here we have BC is 3K and the AB is 4K. If we use Pythagoras theorem in ABC, the hypotenuse AC, so AC square equal to BC square plus AB square. So we don't know AC square. BC is 3K the whole square plus 4K the whole square. So AC square is 9K square plus 16K square, and AC square is 25K square. AC is 5K. So here we put 5K. Now if we can find out our cos and sine. So we know cos A is base over hypotenuse. In this case, for A, you know the base is 4k, hypotenuse is 5k. So cos A will be 4 over 5, and that also we need to substitute. Then we'll find the value of sin A. Sin A will be perpendicular over hypotenuse, and sin A, we know the perpendicular here is 3k, hypotenuse is 5k, so we have sin A 3 by 5. This two will now substitute. We'll now substitute in this expression and show that the left hand side is equal to the right hand side. So we take up the left hand side, and our left hand side is 1 minus 10 square A over 1 plus 10 square A. Now we have earlier found out that 10A is 3 by 4. So we put the values. 1 minus 3 by 4 the whole square over 1 plus 3 by 4 the whole square. That will be 1 minus 9 over 16 over 1 plus 9 over 16. So we take the LCM in the numerator here. So we have 16 minus 9 over 16, and now we take in the denominator will be 16, that is 16 plus 9. The 16 will cancel out, so here we'll get 16 minus 9 over 16 plus 9, which is 7 by 5. Now it is time to substitute the right hand side, and in the right hand side we have cos square A minus sin square A. An earlier slide we have found cos as 4 by 5 the whole square, and sin was 3 by 5 the whole square, which is 16 over 25 minus 9 over 25. So that is 16 minus 9 over 25, and this also is 7 by 25. So the left hand side is equal to the right hand side. So we can say that 1 minus 10 square A over 1 plus 10 square A equal to cos square A minus sin square A, and we have proved. Here in this sum we are going to solve separately the left hand side and the right hand side. Now for the left hand side, it is cosec A minus sin A into sec A minus cos A. Now we know cosec is 1 over sine minus sin A. This is one bracket. Now sec A is 1 over cos A minus cos A. Now in the first bracket we will take LCM, and that is sin A. So 1 minus sin square A. In the next bracket again we take LCM, which is cos A. This is 1 minus cos square A. Now 1 minus sin square A is cos square A, and this is over sin A. 1 minus cos square A is sin square A over cos A. Now here we can cancel sin A with 1 sin A, cos A with 1 cos A. So what remains behind is cos A into sin A. This is your left hand side. Let's go up and see what the right hand side is. So the right hand side, they have given it as 1 over 10A plus cot A. So 1 over, for 10 I'm going to put sin A over cos A, and for cot I'm going to put cos A over sine A. This is the denominator. Again, the numerator I keep as it is. In the denominator, I find the LCM. And the LCM is cos A sine A. So here will come sine A, so it will become sine square. And this will be cos square. Let me just explain the LCM part. So you know the LCM is cos A sine A. So I got to multiply this by sine A and this also by sine A. Here again I have to multiply this by cos A and this also by cos A. Now for the next step we have 1 over, now sine square plus cos square you know is 1 over cos A sine A. Now the division is at this point. Here is your division, right? So what is the meaning of this is 1 divide by 1 over cos A sine A, which is equal to 1. The division I make multiplication, reciprocal cos A sine A over 1. So the left hand side becomes equal to the right hand side. The left hand side was cos A sine A and the right hand side also was cos A sine A. So it is proved. So I've written it once again here, this division here, this division I have made into multiplication and taken the reciprocal. In triangle PQR, right angle at Q, PR plus QR equal to 25 centimeter and PQ equal to 5 centimeter. Determine the values of sine P, cos P and tan P. So we start by saying let QR be x centimeter. Let the side QR be equal to x centimeters. Let me draw the triangle now. So here you have the triangle PQR. Now they said is right angled at Q. So here is Q. Right angled at Q. So I put P here and I put R here. And I've taken QR as x. So I take QR as x. Now look up here what they have said. They have said PR plus QR equal to 25 centimeter. So we have PR, the QR we have taken x equal to 25. So PR is 25 minus x, and let me mark that. So this is 25 minus x. PQ they've given is 5. Now I'm going to use Pythagoras theorem. So in triangle PQR, by Pythagoras theorem we have PR square, hypotenuse square, equal to PQ square plus RQ square. Now PR is 25 minus x the whole square. PQ is 5 square and RQ is x square. So out here we will do a minus b the whole square, a square b square minus 2ab. And that is 25 square, which is 625. 2ab will be 50x plus x square equal to 25 plus x square. So x square I cut. And here I get 625. I bring the 25 on this side, minus 25 equal to 50x. So 600 equal to 50x, and we do 600 over 50 and x equal to 12. So let's go back to the variables. We have taken QR as x, so QR will be now 12. We knew that PR was 25 minus x, so it will be 25 minus 12, which is 13. And PQ is equal to 5. We've got all the three sides and we can now find the values of P. So we'll put the values. Now RQ was given as 12, which was x. Here we found this 25 minus 12, which was 13, and this was given as 5. And we need to find the values of P. So if this is P, here we have perpendicular, this is base, and here is the hypotenuse. So we have sine P, Sine P is perpendicular over hypotenuse, perpendicular r cube, hypotenuse PR, which is 12 over 13. And then we have next is cos P. Cos P is PQ over RP, which is base over hypotenuse, and 5 over 13. Then we have 10P, which is perpendicular over base, and RQ over PQ, that is 12 over 5. Here again we got to prove the left hand side equal to the right hand side. So we have the left hand side is cosec theta minus cos theta the whole square. So cosec we know is 1 over sine theta, and cot we know is cos theta over sine theta. So within the bracket we now take LCM, and the LCM is sine theta 1 minus cos theta. Now this is square and this is square. Now the square is shared by the numerator and the denominator. So 1 minus cos theta the whole square over sine square theta. Now again 1 minus cos theta the whole square. For sine square I am going to put 1 minus cos square theta, because I know sine square is 1 minus cos square theta. Now in the numerator 1 minus cos theta the whole square. So 1 minus cos theta in another bracket of 1 minus cos theta. And in the denominator is 1 minus cos square, a square minus b square, a minus b, and a plus b. Now here I will cancel these two. So you will get 1 minus cos theta over 1 plus cos theta. So we have proved left hand side equal to right hand side. So here we have 1 plus tan theta is sine theta over cos theta. Sec theta 1 over cos theta. Next bracket 1 over cot theta, cos theta over sine theta. Cosec 1 over sine theta. Now we take LCM. In this bracket the LCM will be cos theta. So we'll have cos theta plus sine theta plus 1, and in this bracket here we have sine theta. So here will be sine theta plus cos theta minus 1. Now the numerator we have to multiply, but the denominator is quite small, so we just multiply it straight on. Now let's see what happens to the numerator. So we have cos theta plus sine theta plus 1 into sine theta plus cos theta minus 1. Now this is very interesting what happens here. This is our A plus B, and this is our A minus B. A plus B minus B is A square minus B square. And what is our A? We know is cos theta plus sine theta. And our B is 1 over cos theta sine theta. So in the first bracket A plus B the whole square, A square B square plus 2AB minus 1 over cos theta sine theta. Now again here we have A square plus cos square plus sine square, and you know cos square plus sine square is 1. So this is 1 plus 2 cos theta sine theta minus 1 over cos theta sine theta. Plus 1 minus 1 cancels out. So you have 2 cos theta sin theta over cos theta sin theta. This cancels out. The answer is 2. In the triangle ABC, right angle at B. So here is a right angle. AB is 5 centimeters, so we have 5 centimeters. ACB is 30, so we have 30 here. Determine the length of the sides BC and AC. So let's first start determining AC. We will say let AC be equal to x. Now when it comes to C, we know the perpendicular. Let's mark the perpendicular base and hypotenuse of this. Here is the perpendicular, this is the base, and here is the hypotenuse. So we have taken AC as x, and what is given to us? If you see, what is given to us is AB. AB is given to us as 5 centimeter. We know AC is the hypotenuse and AB is a perpendicular. Perpendicular hypotenuse means we have to start with sine. So we have sine C. Sine C is perpendicular over hypotenuse. The perpendicular is AB and the hypotenuse is AC. So C we know is 30, so sine 30 is AB. AB is 5, AC we don't know, we put it as XAC. So sine of 30 is 1 by 2, 5 over x. So we have x equal to 5 into 2 and x equal to 10. And you remember your x was AC. We have taken AC as x here, equal to 10. Now if you want to find two sides, we already know. This is 90. This is 10. And here we know is 5. We'll do A, B, C. We need to find BC. So we are going to use now Pythagoras theorem in the next step. So in triangle ABC, Pythagoras theorem, AC square, AB square, BC square. AC is 10 square, AB 5 square, BC square. That is 100, 25 minus 25 here, equal to BC square. So BC square is 75. So your BC will be under root 75 and BC is 5 under root 3 centimeter. Now it's given to us sine of A minus B equal to 1 by 2. If you go up to the table, we know sine of 30 equal to 1 by 2. So when we compare both these equations, comparing both these equations, I can now say that A minus B must be equal to 30. I'll put this as equation 1. On the other side here again we have given cos of A plus B equal to 1 by 2. And the table, when I go, I know cos of 60 equal to 1 by 2. And when I compare both now, I will get A plus B equal to 60. Equation 2. I will solve both the equations. We'll add the equation, add 1 and 2. So we have A minus B equal to 30 and here A plus B equal to 60. Adding 2A 90. A is 90 by 2, that is 45. Now to find B, we'll substitute the value in any one of the equations. Substitute A equal to 45, say in equation 1. Equation 1, A minus B equal to 30. So A is 45 minus B equal to 30. So we have 45 minus 30 equal to B. B equal to 15. So B is 15 and we have A as 45. If A cos theta plus B sin theta equal to M, A sin theta minus B cos theta equal to N, show that A square plus B square equal to M square plus N square. So we take the first equation up. and we'll square it. So we have a cos theta, b sin theta equal to m. So squaring, we have a cos theta plus b sin theta equal to m. So square on both the sides. A plus b the whole square, a square plus b square plus 2ab, and that is m square. So I'll put this as equation 3. Now we'll take up the next equation, say 2. This is our equation 2, which is a sin theta minus b cos theta equal to n, and on squaring we have a sin theta minus b cos theta equal to n. We square on both the sides, a square b square. So a minus b the whole square, a square plus b square minus 2ab, 2ab equal to n square. This is my equation 4. Now I'm going to add equation 3 and 4. So this is my equation 3. Below that I'm going to write equation 4. So this is my equation 4. Now see carefully how I'm going to add them up. Here I'm going to take a square common out. So if I take a square common out, what remains inside is cos square plus, here I'm adding, it's not changing sign, cos square plus sin square. One thing done. Now here I'm taking b square common out. So I will take, this is not sin, it is cos square theta. So I'll take b square common out. Now what if I take b square, what remains here is sin square cos square. Sin square theta plus cos square theta. These two are like terms and they will cancel. And here you will get m square plus n square because we have added up the equations. Now we know cos square plus sin square is 1. So a square, this becomes 1. And this is b square. This also becomes 1 because it is sin square plus cos square equal to m square plus n square. So a square plus b square equal to m square plus n square, and we have proved. So in this sum we first start with what they have given us, that is cos theta plus sin theta equal to root 2 cos theta, and then we square. On squaring we'll have cos theta plus sin theta the whole square equal to root 2 cos theta the whole square, squaring on both the sides. A plus b the whole square, a square b square 2ab, and here root 2 cos theta the whole square, root 2 into root 2 is 2, cos theta into cos theta is cos square theta. Now I'm going to take this cos theta on the other side, and that will be 2 cos square theta minus cos square theta. So we have sin square theta plus 2 cos theta sin theta. 2 cos square theta minus cos square theta will be cos square theta. Now I'll take the sin square theta on the other side, and that will be cos square theta minus sin square theta. Now this cos square theta minus cos square minus sin square, a minus b plus b, a minus b, and we have a plus b, and this is 2 cos theta sin theta. So 2 cos theta sin theta, and here it is given to us that cos theta plus sin theta this value. So for here I'm going to put root 2 cos theta. because that value is given to me, and here I'll do cos theta minus sine theta. This cos theta cancels out, so I have 2 sine theta equal to cos theta minus sine theta into root 2. I bring root 2 on the other side. I'll do it in the same slide, and I will get 2 sine theta over root 2. I brought root 2 on the other side, and this becomes cos theta minus sine theta. 2 sine theta over root 2 will become root 2 here. So I'll just do this. 2 is root 2 into root 2. So this is sine theta over root 2 equal to cos theta minus sine theta. So this cancels out. So root 2 sine theta equal to cos theta minus sine theta, and we have proved it. Proved. If x equal to a cos cube theta and y equal to b sine cube theta, prove the following. So x equal to a cos cube theta, therefore x over a equal to cos cube theta, and here we will write y equal to b sine cube theta. So y over b equal to sine cube theta. We have to find the value of this value, means we have to find the value of x over a 2 3, y over b 2 over 3. So let's substitute the value of x over a and y over b. So x over a we see is cos cube theta, we got it here. Y over b is sine cube theta, and once we open the bracket, you have cos cube theta into 2 by 3 plus sine cube theta 2 by 3. So the 3 this cancels. You has cos square theta plus sine square theta, and that is equal to 1. Proved. X equal to r sine a cos c, y equal to r sine a sine c, z equal to r cos a. We need to prove this, so we just take up the right hand side, x square plus y square plus z square. We'll put the value here, x square, put the value of y square, put the value of z square. So we saw x square, here we get r sine a cos c, y we know is r sine a cos c, and this is r cos a. Open the bracket, r square sine square a cos square c, open the bracket here, r square sine square a sine square c, r square cos square a. Now within these two I can take r square sine square a common out, so I'll take r square sine square a common out. What will remain inside here, cos square c plus sine square c plus here r square cos square a. Now for the next step we have r square sine square a. Now this is cos square plus sine square is 1, so r square cos square a. Now for the next we will take r square common out. So what remains inside, sine square a plus cos square a. Now sine square plus cos square is 1, so that is r square into 1. So the answer is r square. So we have proved r square equal to x square y square plus z square. You find the value, we need to put the value. First is 10 square 60, and that would be root 3 by 2 the whole square plus 4 cos square 45. Cos 45 is 1 by root 2 the whole square. 3 sec square 30. Now for sec square 30 it will be 2 over root 3 the whole square plus 5 cos square 90. Cos square 90 is 0 over cosec 30. Now cosec 30 is 2. Sec 60 is also 2, and here this is root cot 30 root 3 the whole square. So root 3 into root 3 is 3. This is 4 into 1 by 2 plus this would be 3 into 4 over 3 plus 0 over here 2 plus 2 minus 3. So this cancels 2. So you have 3 plus 2 plus 4 over 4 minus 3. And this is 9 over 1. So the answer is 9.